All right, welcome and thanks for joining for our last section in Chapter 8. So in 8.7, what we're going to be talking about here is probability. Now, I'll let you know beforehand that some of the definitions that we're going to be doing here are pretty lengthy definitions for things that are also pretty easy to actually do. So just talking about the probability of an event in general, the way that we define that is if an event E can occur n different ways, so we'll start with that. If an event called E can occur n different ways, then the probability of a specific event E, then the probability of a specific event E is the ratio of ways the specified outcome is the ratio of ways the specified outcome can occur. Come on, we could do this. There we go. The specified outcome can occur to the total n ways E can occur. So again, that's a pretty lengthy definition of probability. And what it's really saying is when we're talking about probability, we talk about it as really your number of successes, where success represents what you were trying to get. So it doesn't necessarily mean it's a good thing. It just is a success in terms of it's correct for what we're looking for, over the total number of possibilities, or the event happening out of the number of ways that it can happen. So that n, that total, what that really is what's called our sample space. Your sample space is really the list of all outcomes for an event. So it's the list of all outcomes for an event. Sorry about my weird spelling of outcomes. Correct, but that S. All right, so we're going to be doing all 6 slides today, just because, it's only 6. We usually do 5. They're short. So an example of sample space, you flip a coin 3 times. Find the sample space for this event. So we'll start with, it's possible that I got a heads, then a heads, then heads. Or heads, heads, tails. Then it's also possible that I got heads, tails, heads, and heads, tails, tails. Next, it's possible that I got tails, heads, heads, versus tails, heads, tails, 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 or tails, tails, heads. So these are my only 8 possibilities of what I can get flipping this coin 3 times that are all, different possibilities. So this is the actual sample space. The sample space isn't 8. It's the actual list of the different things that can occur. So now if I ask for the probability of attaining 2 heads and 1 tail from this event, I'll switch this to blue. So we're looking for 2 heads. That happens here, here, and here. So it's a total number of 3 successes, 3 times when I was successful in getting 2 heads, out of a total possibility of 8. There were 8 options. So again, this is 3 success over total. So 3/8. If I switch that and now ask for the probability of attaining 2 or 3 heads from this event, so I count all these ones where I have 2 heads, but I also count this one. So that's going to be 4/8, which, just like every other time with a fraction, we reduce to 1/2. All right, another example, and this one has to do more with cards. Sort of the common things that we'll work with are going to be cards, dice, and then maybe some heads and tails. So drawing a card out of a deck of cards, there are 4 suits: hearts, diamonds, clubs, and spades. Those are different types of suits for cards. The numbers that you have are 2 through 10. And then you have Jack, Queen, King, and Ace. There's 13 of each suit, so there's 13 hearts, 13 diamonds, 13 clubs, and 13 spades, because there are 13 of these. And there's 52 total cards. So just some stuff that you might sort of need to know to answer some of these questions. Find the probability of drawing a 2. So first, the number of successes. How many 2s are there? Well, there's a 2 of hearts, diamonds, clubs, and spades. So there are 4 2s out of 52 cards, which again, just like always, we're going to end up reducing that fraction, so we get 1/13. It's quick, easy. Find the probability of drawing a red face card. So for 1, if you're not sure what a face card is, that would be all the jacks, queens, and kings. So there's 3 face cards, but we want just red face cards. So there are 3 hearts. There's 3 face cards that are hearts, which are red. And there's 3 face cards that are diamonds, which are red. So 3 here, 3 here. That's a total of 6 out of 52. And when I reduce that, I get 3/26. Find the probability of drawing a black card less than 8. So first, let's deal with this less than 8. How many cards are there that are less than that? Well, there's the 2, 3, 4, 5, 6, and 7. So there are 6 different cards that are less than 8, and we want any of the black ones. So the clubs are black, so there's 6 clubs that are less than 8, and then the spades are black as well. So there's 6 spades that are less than 8. So we have 6 and 6, which is 12 over 52. And when I reduce that, I get 3/13. All right, so those are our 2 sort of prime examples here. Now we're just going to have some more definition-like stuff. If we want to talk about the probability of an outcome not occurring, so if an event does not occur, that would include all other outcomes. The thing you have to be careful about with a question that says not occurring is it's not exactly the exact opposite of it occurring. So to give an example of what I mean by that is if we're talking about the probability of winning and the probability of not winning includes losing, but it also includes something like a tie. So it's not as cut and dry. So just be careful about that and make sure that you're realizing that the probability of an outcome not occurring is all other outcomes, not just the exact opposite. So this is known as the complement of an event, and the way that this is written is the probability of the complement is 1 minus the probability of the event happening. So our probability is always going to be between 0 and 1. It's going to be a decimal. And the complement is just the thing that would get it to be 1. It can also be the probability of all other outcomes, which again doesn't mean the exact opposite outcome. It just means all possibilities. All right, some more longer definitions. A probability of event A or B happening. So if I'm asking, hey, what's what's the probability that this or this happens? The way that that can be found is by finding the sum of event A and event B. So it's going to be the sum of event A and event B. Maybe we want to add the sum of the probability. So we find the probability of A, we find the probability of B, then we add them if the events are mutually exclusive. And when we talk about mutually exclusive, what that means is that they cannot occur at the same time. And then the way that we write this is the probability of A in union with B, meaning or, is going to be the probability of A plus the probability of B. So that's for an or statement that is mutually exclusive. Next, we have an and statement. And the way that that probability is found is the product of the probability of A and B, or of event A and event B, if the events are independent. And what we're talking about when we're saying that they're independent is that neither of them causes each other. So the way that this is written is the probability of A and B. It's also like that intersection symbol. And again, this can be found by doing the probability of A times the probability of B. And then last, we have our other or statement. So the probability of event A or B occurring if the two events are not mutually exclusive. And again, what we mean by that is that they can occur at the same time. Then what we do is we take the probability of A plus the probability of B. So same starting off, we add the probability of event A, we add the probability of event B, but then what we have to do is take out the probability that both of these things are happening at the same time. You sort of have a Venn diagram that comes along with this. These are terrible circles. I think I have a circle tool somewhere in here. So we can have a Venn diagram. Yeah, these are ovals, that's okay. If we said that this was the probability of A and this was the probability of B, we can't just add these two together and say that's our overall probability, because what we need to do is take out this overlapping piece, which is the probability of A and B, because otherwise you're counting that twice. You're counting it for probability A and probability B. So that's what we would end up taking out. Again, most of the questions that we're going to be dealing with are going to be things like these decks of cards. These questions in particular, these decks of cards ones, are ones where you do have this happening a lot of times, or sometimes. I won't say a lot of times, but some of the time you can have an overlap there. So just be aware of these. A lot of times you'll use them without even necessarily realizing that you're using them. And then also make sure that you know this complement one. It's going to be important. It's so unbelievably easy because you're just doing 1 minus the probability. All right, so that's all of 8.7, examples and notes. Feel free to get started on some of that homework. And again, if you have questions, make sure that you go through the notes, just jot down where you had a question, and we can start off by answering those.